welcome. Today let's try to solve another Leetcode problem. 1010 pairs of songs with total duration divisible by 60. So for this problem we are giving an array time, but this array gonna be very long. As you can see, it is 6 times 10 to the power of 4. It means O(n) squared is not possible, so we have to reduce the time. Yeah. And we need to find a pair of numbers, which is the sum of them modular 60 equal to 0. Yeah, we need to find such pairs. So for example, 30 plus 150, it is 180. It is divisible by it is modular to 60 equal to 0, and also for 120 and 60. But how should we solve such problem efficiently? Efficiently. So we can use the mathematics skills. We can use the modular theory. So for the modular theory, so we want to find a number. Let me give you an example. So for example, let's try to understand the modular theory. So if a plus b modular c should equal to a modular c plus b modular c, and then the result should be modular c. So you need to understand the modular theory about that. So let me give you an example. So for example, a is 20 and b is 40. So c is 60, right? Modular 60. So let's try to understand it. So a plus b modular c should equal to a modular c plus b modular c, and the sum of them would be modular c. So for example, 20 plus 40 modular 60, it is 0, right? And a modular 60, 20 modular 60, it is 20, and 40 modular 60, it is 40. So 20 plus 40, 60 modular modular 60. So 60 modular 60 should be 1, right? And here 60 modular 60 should be 0. And here is 0, and there is also 0. It means it's the same. If you understand this theory, so you're gonna solve this problem easily. So we can prepare count should be from 0 to 60, because according to the modular theory, we're gonna modular all the numbers to 60 and get the result, and then we're gonna check the result according to the requirement. So for t in time, we can get the result. So say t modular 60 should always be inside of the array. Should plus equal to 1. So we're gonna count how many such numbers, and then we're gonna use the two sum to get the result. So for example, one number is 20, another number is 40. So we can use two sum to get the result. It means how many 20, there's only 1, and how many 40, there's only 1. It means 1 times 1, there's 1 a pair. Now let's try to solve it. So we can use for I in range from 1 to 30. It means we only need to count the numbers. We only need to count the numbers from 1 to 29. Because for 0 and 30, we're gonna check it differently. It's gonna be different. So let's check the 1 to 29 first. So let me prepare result would be equal to 0, and the result should plus equal to, and this is the two sum part. So it's gonna be the ci times c 60 minus I. So this is the two sum part. So but what if the what if it is equal to 0? It's gonna be differently. So the result should be plus equal to the 0 and the 30 part. Yeah, so if it is a 0, so for example we have something like yeah, so for the number maybe we have something like 60 and 60, so we're gonna calculate it differently. So for example, if we have two 60s, how many pairs? So it's gonna be n times n minus 1 divided by 2. Yeah, so it's gonna be C0 times C0 minus 1 and divided by 2. So what about there's only one 60? If there's only one 60 and how many pairs? So C0 means for this 60 there's only 1 minus 1, it is 0, it means it's not possible. So this is the formula, and then we're gonna check how many 30. Yeah, so it's gonna be the same. Let me copy the code. Yeah, we just need to change this one to 30. So this means how many 30s? Yeah, if there are more than 2, we're gonna use this formula. If it is only 1, it's gonna be 0. So actually this is the result. We just need to return the result. Yeah. As you can see, it works. Now let me submit it and then analyze the time complexity. As you can see, it's pretty fast, and it's almost the fastest ones. It means this method is the best one. And let's analyze the formula first. So this formula actually is invented by Chinese people. I don't know the name, but it is very famous. Yeah, so we call it a modular theory. It also includes a lot of other, like the plus, minus, division, and times. Yeah, it's gonna be similar, but for this problem we're gonna use the plus modular theory. If you understand the theory behind it, it's gonna be easier to solve the problem. Yeah, so the time complexity would be O(n). Yeah, because we only need to traverse the time array and then check the result according to the two sum and the mathematic formulas. I think for this one it is the mathematic formula. I think you should understand why C0 times C0 minus 1 divided by 2. Yeah, because for this part we're gonna check like how many 60s. Yeah, because we have I'm sorry, we're gonna check how many zeros. We don't have 60. We only have 0 to 59 according to our theory. And how many zeros? Yeah, if there are more than 2, we're gonna use this formula. If it is only 1, it is 0. Yeah, and for the 30, it's gonna be the same. Yeah, as you can see, 30 plus 30, it is also the result. But for here, we didn't count the 30. Now we need to check the 30. It is this formula. Yeah. Now let's try to check other ways. Maybe you don't understand the modular theory. You can't think about this method, or you can try to use other ways. For example, from the beginning, I used some other ways. It is really slow. Let me just check the code. Yeah. Let me check some of the code. Maybe here. Yeah. So if we don't use this modular theory, maybe we can use a counter. It's gonna be similar, but it's really easy to make mistakes. So for the counter, you can use a counter or hash table, and you put the key value pairs, append the array, and inside of the array you're gonna check. Yeah, and you have also needed to check two parts. Yeah, because if you directly use the time array, it's gonna be time limit exceeded. But you can check here. The time I is more than or equal to 1, less than or equal to 500. It means if we put it inside a counter, so the length of the counter would be at most 500. It means we can pass, because 500 times 500, it is still a small number. Yeah, that is why we can use it. So let's analyze this part. So this part is just the two-sum part, but this is the brute force of two-sum. Yeah, we're gonna check one by one, and then if it is modular 60 to 0, so we're gonna use the result plus equal to how many of the first number and how many of the second number. So this is for this part. But what if the numbers inside there is 30? So we need to use the formula to check it. But here we also need to check if the value is more than 1. If it is 1, it is 0. I think if it is 1, it is still okay. If it is 1, it is still okay. I don't need this if check. Now let me just submit it. Yeah, as you can see, it also works. but it is much slower. It is only 5%, and you can say it is 150 milliseconds. Yeah, because this is n square and this n is 500. And here you're gonna make mistakes because sometimes you didn't understand why it is modular 30 but not 60. Yeah, if it is a 60, you're gonna miss some testing cases. So for example, inside there may be maybe 30 and 30. You have to check that. Yeah, or inside maybe 90 and 90. Yeah, if you modular 60, you're gonna miss such testing cases. Yeah, because 90 modular 60 it is not equal to 0. But we need to modular 30. So in this one, we can find how many pairs of it. Yeah, if there's only 130, it's gonna be 0. So if there's more than 130, yeah, we can use this formula. It means it is always right. Yeah. Thank you for watching.